Hello, everyone, and let us talk today about chemical energetics. Chemical energetics is the study of energy changes in a reaction, mainly heat. During a chemical reaction, there is heat changes or energy changes. So I have two options. Either heat is given out from the reaction to the surrounding, or heat is taken from the surrounding to the reaction mixture. Now, if heat is given out to the surrounding temperature will rise naturally because heat is given to it. While if you take heat from the surrounding, the temperature of the surrounding will decrease if you measure it by a thermometer. Remember that a thermometer reads the temperature of the surrounding, not the reaction itself. So, in definition, we say that an exothermic reaction is a reaction that releases heat to the surrounding, and an endothermic reaction is a reaction that absorbs heat from the surrounding. For example, if you're burning wood, it will release energy. But there is a term that we must familiarize ourselves with, which is called activation energy, meaning it is energy supplied for the reaction to start. The minimum amount of energy for the reaction to start is called activation energy, while enthalpy change or energy change is the transfer of thermal energy during a reaction. Remember that it can be taken from the surrounding or given to the surrounding. Let us look at the energy profile. For any reaction, I make an energy profile showing the energy of the reactants and the energy of the product. For an endothermic reaction, energy is taken from the surrounding because the reactants don't have enough energy to produce the product. Therefore, they take the energy, which is this blue arrow, from the surrounding. What about that pink arrow? This is the energy needed for the reaction to start, and it is called activation energy. If you look at the energy profile, two things will tell you it's an endothermic reaction. Number one, energy of the reactant is less than energy of the product. Number two, delta H or energy change is the arrow pointing up. If you look here at the energy profile without the activation energy, it sums up this process. Reactant energy less than the product energy. Delta H arrow is pointing up. If it is pointing up, it is positive because the energy of the reactants increased. That's why delta H has a positive value. Examples of endothermic reaction is thermal decomposition, or you're breaking down a compound using heat, which means this is not going to happen without heating. That's why it's endothermic. Number two, photosynthesis, endothermic with a positive delta H because you need energy from the sun. Number three, electrolysis. If you guys remember, we need electrical energy, and even if the compound is molten, we will need heat energy as well. Although melting and evaporation processes are physical changes, not chemical, but they will not proceed without supplying energy or heat. Now let us talk about the exothermic reaction energy profile. Look here, you will see that activation energy is still present, albeit a bit smaller than the endothermic reaction. But now look at the energy of the reactants and the product. Products are less than the reactants. Therefore, heat is lost to the surrounding and the arrow is pointing down, making the delta H negative because the system lost energy. So if you look at the reaction energy profile, two things will tell you it's exothermic. Reactants energy higher than the product energy. Number two, delta H arrow is pointing down, making the value of delta H negative, as seen clearly for the energy profile without the activation energy. Examples of exothermic, which are reactions that will release energy, causing the temperature of the surrounding to rise, is most neutralization reaction. Any fuel combustion or reaction with oxygen, of course, is exothermic. Freezing and condensation processes, which are physical processes, they also release energy to the surrounding. So in summary, if you look at the energy profile of an exothermic reaction, you find the reactants higher than the products, delta H pointing down, and the energy profile of endothermic reaction, the opposite. Energy of the reactants is less than energy of the product, delta H will be pointing up with a positive value. Thank you all.